Hello and welcome to Jenkins with StorageOS. Today we're going to do a demo. First of all, we're going to install Jenkins, but before that, let me show you the context of our cluster. What actually are we running? We have 4 Kubernetes nodes. Happens to be that they're in GKE. They could be in any other platform, bare metal, or cloud. We have StorageOS installed. StorageOS installed the four daemon sets alongside the scheduler and the CSI helper. So we have one pod of StorageOS per node, and the storage classes. The fast storage class is installed by default, and we have created the StorageOS replicated storage class. Also, StorageOS creates a service when it installs, and that service will be used to access the API, so the user interface of StorageOS. That is just a port forward that we are accessing. So from this computer on localhost, we can see in the 5705 port the StorageOS user interface. In the same way that user interface accesses the StorageOS API in the same way that the CLI could do. Today we're using a public repository, so all the YAMLs that we're going to use for this demo are available in GitHub in the use cases StorageOS repository. So let's start by creating the Jenkins installation. We're going to use the stateful sets. We're just creating the resources, and now we will show you exactly what we have created. First, the stateful set will create the pod, Jenkins master 0, and a persistent volume claim associated to this pod. Let's have a better look at that persistent volume claim. StorageOS dynamically provisions the persistent volume, so you don't have to worry about this just by asking for a claim. So an application asking for capacity is enough. And we're using, as we said before, the StorageOS replicated storage class that will enforce one replica of StorageOS, so 2 copies of the same data. Now let's have a look at the configuration and secrets of that Jenkins. We have specified the secret with the username and password, and we're going to stick by the simple defaults, and then a config map that can hold the Jenkins configuration. That Jenkins configuration will be used by different plugins that actually we can define from a fairly declarative point of view. Of course, is a Jenkins server in the end, and we can execute the installation of the plugins at Bootstrap as we could do in a normal or in a standalone Jenkins server, yet this is done for us at Bootstrap time. Now, let's have a look at the stateful set. Stateful set is a Kubernetes controller that will enforce, in our case, one instance of the application, so what is called one replica of the application. That stateful workload or that controller is used for stateful workloads. We're going to use a Jenkins standard image for the init container in the same way that we're going to use for the main container. The volume mounts are the same as well. And you can see that there are a few volumes in here. I would say that the important one is the Jenkins config and the Jenkins home. Both of them are really important for normal functioning. The rest of them are temporary directories that are ephemeral. So we need to persist the Jenkins home and of course its configuration, which is read-only in this case because it comes from a config file. We can see that the init container and the main container have the same volume mounts. To see those volume mounts, exactly what they are, we can see that the plugins there, the secrets there, etc. are just ephemeral entities that are bound to that host. Every time we start the container, those directories can be lost. However, we need for the Jenkins home to persist our data properly, and for that we're going to use StorageOS. So in this case we can create a template, a volume claim template that will enforce that there is one persistent volume claim for the Jenkins home associated always to that container. If we create more containers, more persistent volume claims will be created. The only thing we need to do is to reference the storage class. In our case, the StorageOS replicated one. Let's have a look at the pods, so we can see that Jenkins already started. We're going to use a port forward once again to access from our machine, from the machine or this laptop to the port of the Jenkins server. You may appreciate that there are two services, the Jenkins one and the Jenkins agent. We will see later on what the agent is for. For now, we're going to use the port 8080 to access the user interface of Jenkins. Great, now we can use those credentials that we defined in the secret. Of course, they were in base64, so we didn't see them. Great, we have a Jenkins server running in a couple of minutes. That's absolutely great. We are leveraging Kubernetes to do this great task. Now, we have installed the plugin. By default, in that configuration file, we have told to install the Kubernetes plugin. That plugin will allow us to use to leverage the Kubernetes control plane or functionality to provision new pods easily, to create new agents to run our applications or our jobs from Jenkins. So let's go and configure some jobs. This will be an interesting test. Let's create just a dummy project. And actually, let's create a small dummy script. Of course, you could have pipelines and you can have very sophisticated build procedures. Now we just want to see how Jenkins behaves in Kubernetes. So let's create this small dummy script that will just sleep for, let's say, a few 35 seconds. So a few seconds, a bit more than half a minute. So we can see the projects running around. And let's just build it. Of course, the first time that it starts, this is a Java application, it takes a bit of time to bootstrap, but we will see how Jenkins connects automatically to Kubernetes and starts creating pods. So we have the Jenkins master, and we will see how long it takes to start having an executor, so an agent. Right now, the master is not running any agents, so let's have a look if the agent has started. We can see now that the default -0 is a new pod that has started in 20 seconds ago. That is actually that agent, the agent that will run the job. So we are launching. The first time takes a bit longer, of course, to bootstrap than the other times, and we get our job just running. In a few seconds, we are leveraging Kubernetes to create pods that will be our agents. However, those agents can be ephemeral. We want scalability and we want parallelism as well. So let's create a few projects with the exact same base of kubecon1. So we're just gonna have that tiny script that sleeps, and we will be able to do a different test. We will be able to run different jobs at the same time and see what happens. So bear with me here, let's create just a few more projects. And one test I think it's interesting is creating more projects and nodes, because you may wonder, okay, is Kubernetes creating one pod per agent per node, or one pod per task, or one pod per execution? So we will see here that even though agents can be reused, agents can be started real fast. So we can have different executions of the same multiple times leveraging the orchestrator. So actually we can have a real look. We're running the same script once again, and we have the 5 projects already. The first project, the kubecon1, already finished our dummy execution. And let's go have a look how the logs look like. So we just have the echo running in kubecon and it finished successfully. Very simple job, but actually we have proven that we can use agents as bots. You can see that when the job is finished, it just terminates its bot, right? That means that we can have significant scalability. We don't have to be configuring by hand all our agents, for instance, for in this case, a Jenkins farm. We don't have to configure a farm. Just by having a Kubernetes cluster, we can already create a simple Jenkins farm in a very nice way. So let's create all the jobs. I just run jobs at the same time. Let's rerun kubecon one as well. And now we can see in our real-time dashboard using K9S, which is a simple, actually not simple, but really nice way of looking at Kubernetes objects in real time. And we can see that pods are starting, agents are starting, and in a matter of seconds, we have the executions of those jobs independently. We can see that some of them are launching, some of them are running. What we would expect in a real live CI/CD environment. We have multiple jobs, multiple development teams, or multiple projects that are just creating jobs. For instance, we would trigger based on the source control commits and trigger builds automatically. So we could see that every build could be independent of each other. We wouldn't need to have a really big Jenkins master. We can just delegate into agents and simply create a farm of Jenkins with Kubernetes. Jenkins is great to run jobs and to do CI/CD, but actually is not really designed for orchestrating tasks in a distributed environment. Of course, it has all the agents and you can build farms, and it works great, yet we can do better. And I believe this is more convenient for teams to run. Of course, it depends the scenario and the development teams that what you need and how you need to persist, for instance, artifacts, etc. But actually, we can see that agents just attach and detach as soon as we need them. We have an on-demand platform of Jenkins executioners. Great. We can see once again that when they finished, all the pods are gone. Why should we be using machines that are doing nothing for Jenkins when we can be running other things at the same time and use for Jenkins jobs when they're needed? Now, let's do another experiment. Let's do another test. Let's create a job that will take a bit longer to stop or to finish in this case and run it. We have the job running. Great. Now let's see what happens when we lose the Jenkins master. Remember that pod coming from the stateful set is backed up by StorageOS, by a StorageOS volume that is actually replicated. So we can see in the StorageOS UI that the pod is attached in the node RxV7, while the primary data is in the node FNPC. Also, it's replicated, so it is enforced that there is 2 copies of the data. It has 1 replica, and StorageOS implements synchronous replication, which means that every single point in time, the data is exactly the same in the primary volume and in its replica. So let's cordon the node where the Jenkins master is running and stop that pod. So we are enforcing by cordoning that node that the stateful set controller will have to create that pod or schedule that pod in a different node altogether. So let's delete the pod and let's see actually where it starts. It doesn't matter where it starts for StorageOS because StorageOS implements internally a protocol that gives access to the data anywhere in the cluster. So we can start our Jenkins pod anywhere, and StorageOS will give it its data. So let's run the init container, or actually it runs the init container first, and then it will bootstrap Jenkins. That will take maybe 1 or 2 minutes, maybe more, to bootstrap all the configuration, the Java application, etc. In the meantime, let's have a look once again where StorageOS sees the volume attached. You can see that still in a different node. The primary data is in FNPC while the mount is in a different node. Of course, when the data is in the same node as the application, which actually we can ask StorageOS to do by using the StorageOS scheduler. So we influence the Kubernetes control plane, the Kubernetes scheduler, to alter where the pods run. We can guarantee or enforce best performance and lowest latency. So we run the agents as pods, we fill the Jenkins server, now Jenkins is started, and it's still in a different node where the data is stored. Usually for Jenkins, performance on the input-output operations is not the most demanding. If we compare, for instance, with a database, yet is important that data is always accessible. Just to have a look internally while Jenkins starts, let's have a look actually the procedure for starting a pod that attaches a volume. The kubelet attaches the volume that the StorageOS volume, and then when that is ready, it starts the container, and that container has a mount point, and that mount point is the StorageOS volume. Of course, you don't have to go in that much detail if you don't need to, but it's always interesting to understand what happens under the hood. Great, Jenkins is already running. And let's retrigger the port forward to the port because we stopped it and restarted. Let's go have a look. And we can see that all our jobs are still there. We have persistence for our Jenkins server. It can start anywhere in the cluster and just start up and run. We can finish that the jobs are in complete state. And once again, we have persisted our CI/CD server that actually is running on a Kubernetes from a Kubernetes fashion. We can retrigger a job, for instance, kubecon1, and we can see that it just runs again. So we just restarted our pod and everything keeps working. Now, let's have a look what exactly Jenkins sees internally when we have this data persisted. How is that possible? Well, if we look internally connecting to the Jenkins shell, we can see that the bar Jenkins home, obviously where the files are stored, is a mount point for the StorageOS volume. And no matter where that container starts or where that pod starts, that Jenkins will be there. Those Jenkins files will be there. Finally, I encourage you to use the documentation, the StorageOS.
Thank you very much, Ferran, for that demo. Do we have any questions?
We do indeed. So first question, what are the advantages of running CI/CD inside Kubernetes with StorageOS as opposed to on standalone machines or VMs?
Well, so one of the advantages to running CI/CD inside Kubernetes and with StorageOS in particular is that you can have multiple CI/CD environments. So, for example, you could do things like having, one Jenkins server per project, per team. I think, for anybody who's managed a Jenkins server before, I think we've all been in that situation where all of a sudden you have a Jenkins server, it has, a million different plugins, and it's becoming extremely unmanageable to manage. By reducing the kind of scope of the Jenkins server, it becomes much easier to manage. The other thing is that by using agents as pods, or pods as agents rather, we can get much more efficient utilization of our resources in the Kubernetes cluster. So, for instance, if you make sure to set resource requests and resource limits on your agent pods, then Kubernetes can take care of, bin packing things such that your nodes are being used efficiently, and you're not just wasting resources. Additionally, if you have services that are, consuming a lot of resources, then, Kubernetes can make sure to schedule those away on other nodes. And lastly, StorageOS creates PVCs, in a matter of seconds. So it's particularly efficient to use StorageOS to store artifacts as part of CI/CD pipelines, because it's very quick to provision volumes. So there's not, you're not adding any kind of significant waiting time to your pipelines.
That's brilliant. Thank you. A couple more questions. So guys, anybody on the call who's got any questions, please do submit them. Next one is, can StorageOS help with other CI/CD technologies such as Argo and Flux? So we focused on Jenkins for this demo, of course. Can StorageOS help more widely with CI/CD?
Absolutely. So for anybody who's not aware, Argo CD and Flux are two projects that are, particularly modern and kind of, designed to be run inside Kubernetes. So they hold their config in CRDs rather than as Jenkins does in a large XML file. But StorageOS can absolutely help there as well, particularly with regard to having somewhere to store your artifacts. So, if you have test clusters or whatever, and you're running CI/CD building, test pipelines, StorageOS could then hold the artifacts of those builds. For example, running something like Artifactory or some other kind of artifact management. And then once you've run your integration testing against those artifacts, then you could, promote those to whatever your production Artifactory management or artifact management system is.
That's great. Thank you very much. Okay, I think that's all the questions we have for this webinar. So just remains to say, one more question has just come in. Does StorageOS for CI/CD support chat authentication?
That's not something that StorageOS itself implements. StorageOS is just providing the backing for whatever your CI system is. So if your CI system implements chat, then you could run that on top of StorageOS if that's what you wanted to do.
Indeed, so standard Jenkins configuration there.
Exactly.
Great, okay. I think that is the last of our questions. So it remains for me to thank everybody for attending. Thank you very much for your time, and see you in future sessions.
Thanks very much.